Yeah. Yeah. Good evening, all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes.
Yeah, it's visible.
Yes.
And
Thank you. So myself, I'm Vijay. Like I hold 20 plus years of experience, which includes nearly 10 plus years of experience in big data environment like Hadoop Spark environment. So as part of today's demo, I'll be covering the following topics. So before I go right, this is will be here in this we are providing knowledge on this Hadoop, PySpark, and also knowledge on Python. So all these three are included: Hadoop, PySpark, Linux, and Python. So everything goes in the Linux environment. So you'll be briefed before we go with the actual practical part. So starting with this, right? What is big data? Why Hadoop? Why Hadoop required? Drawbacks with the current databases. Drawbacks with the current databases. Hadoop and PySpark advantages. Hadoop and PySpark job market. So starting with this, what is big data? So the name itself saying that huge volumes of big data, right? Big data, the huge volumes of data. Currently, the data is getting stored. What are the data storage units? What are the data storage units, right? Data is stored. The data storage units like KBs of data, MBs of data, GBs, terabytes, petabytes. Beyond that, we got exabytes, so terabytes, yottabytes, right? But today, data is generated in petabytes. 1 petabyte equal to 1024 TBs. 1024 TBs. Already 1 TB is a large storage unit, right? So examples of petabytes of data generation. Examples of petabytes of data means we take about any banking sector. If you talk about any bank like SBI or HDFC. So within the city, we see hundreds of branches for it. Within the entire state, like thousands of branches for the SBI. Within the entire country, lakhs of branches for this. Again, in each branch, millions of customers. Each customer making multiple transactions. Each customer making multiple transactions like per day, per hour, per day, per week, per month, right? Each and every transaction has to be stored. Each and every transaction has to be stored, right? Yes. So what is the data generated? What is the data generated, right? Huge data in petabytes. Forget about this. You are aware about Facebook, right? Yes. Facebook has got users throughout the world. Millions and trillions of users for Facebook. In a minute, how many posts and videos? And we need to store all the videos and posts, right? What is the data generated by Facebook in a minute? Not only Facebook. Today, like if you see, many of the applications are generating data in petabytes. Talk just a 1 minute transaction. Just take 1 minute transaction, data is generated in petabytes. Example like Facebook is the one. You see everyone querying in the Google. What is the data generated by Google, right? Google queries. Or like Twitter tweets keeps on generating Twitter tweets. And if we talk about that YouTube videos upload, YouTube videos upload, right? What should be the storage capacity for storing all the videos? Just now I was talking about this bank transactions. Bank transactions, right? Lakhs of branches, millions of customers making multiple transactions, and even email or Gmail messages. Email messages. What should be the storage capacity to store all that millions and trillions of users using this email messaging, and to store all these millions and trillions of messages, right? Huge storage. And here also, like telecom transactions in e-commerce, like Flipkart and Amazon transactions, e-commerce transactions. Everywhere we see like huge data is getting generated. Currently, we have got databases, right? Currently, we have got databases for storing these things. Like we have got a databases, like Oracle database, MySQL, SQL Server, right? We have got Oracle, MySQL, SQL Server, DB2. These are used for OLTP, online transactional processing. But we have got some specialized databases. We have got some specialized databases used for data warehouse purpose, right? If you heard about the Teradata, Netija, Teradata and Netija, Vertica. Teradata, Netija, Vertica for OLAP operations for data warehouse. These are used for data warehouse, OLAP operations, online analytical processing, right? But these databases are specialized databases. They can handle data up to some extent. But as a solution to all the storage level problems and processing level problems, right? So we have got a framework called Hadoop. So later I'll come back to this. What are the services provided by Hadoop? But before that, you need to see the data, sources of the data, and the types of data, right? From where the data is getting generated, where this huge data is going to be generated from. If you talk about this data has got experience, data has got future reference. So if you see what is the data generated from the last 50 years, this is the data. This is the data which in the entire real world, which has been generated from the last 50 years, 1974 to 2024. So this data, if you observe, especially from the last 10 years, from 2014 to 2024, the last 10 years with the previous 40 years. So nearly only like 80% of the data what we see has been generated from the last 10 to 15 years. Previously, only 20% of the data you can see which was generated from the previous 40 years. In 1980s, 90s, or early 2000s, right? So we see like data in the form of KBs, MBs, like they used in 1990s, like floppy disks. Later, like CDs in MBs of data, DVDs. Later, you got to USBs, right? What is the reasons for this huge data generation? Huge data generation, right? Today, not even GBs, TBs is not sufficient, right, for storage. So reasons for huge data storage is usage of technology, usage of smartphones, usage of internet has increased a lot. Because of this usage of technology, usage of smartphones, usage of internet, huge data is getting generated. Yes. What are the main sources from where this data is getting generated? Mainly three sources of data. Three sources of data. Social data, machine data, transactional data. Social data, machine data, and transactional data. Social data, right? Social data. Data which has been generated. social data which has been generated from the social sites, right? Like Facebook, Twitter, all this. Machine data which has been generated by reading or scanning the barcodes, RFID chips, all this data we call like machine data. Transactional data like day-to-day operations, right? Like bank transactions, telecom transactions, right? Yes. And mainly it is going to occupy like three types of data. Structured data, semi-structured data, and unstructured data. Structured data means data which is organized in the form of rows and columns. Data which is organized in the form of rows and columns in a structured format. Which is organized in the form of rows and columns in a structured format like database tables, Excel files, semi-structured, right? Like XML files, JSON files, which are not fully structured, which are not fully unstructured. Unstructured data, like chart messages, articles, images, videos, all these things, right? So today, the biggest challenge is to handle this unstructured data, right? Data, most of the data we see in unstructured format. Databases can handle only structured data in the form of rows and columns, but unstructured data, right? So Hadoop can handle all varieties of data like structured, semi-structured, and unstructured. Just a second. As day by day data is increasing enormously, we need to have proper storage systems and processing systems to handle this huge data, right? So as a solution to all the storage level problems and processing level problems, so we have got a framework like Hadoop. Hadoop is mainly meant for two things, storage and for processing. Meant for both storage and processing. Any technology either performs either storage or processing. We talk like C or C++ or Java, .NET, all these are meant for processing. We talk like Oracle, MySQL, SQL Server, all these are meant for storage. They are either storing or processing, but Hadoop performs both storage and processing. And that too, for storage, does Hadoop use any databases internally? I was saying like there were some drawbacks with the databases. Despite with the drawbacks, Hadoop is not going with any databases. It is going with a special kind of file system called as Hadoop distributed file system. Hadoop distributed file system. And for processing, right? And for processing, it is going with an execution model called as MapReduce. Currently, it is going with Spark. Previously, it was using MapReduce. Now it is going with Spark execution model, right? So for storage, it doesn't use any database. It is using a file system called Hadoop distributed file system, and for processing is going with MapReduce on Spark. Okay. So why databases are not used for storing Hadoop's data? What are the drawbacks with the databases? Drawbacks with the current databases, right? Yes. Drawbacks with the databases. First drawback, most of these databases limited storage, right? In GBs or in TBs, in GBs or in TBs. Limited storage. Secondly, no parallel processing, no parallel processing. In most of the databases, no parallel processing. Parallel processing is parallel processing is 1 second. So here, if you see master, multiple slaves, single master and multiple slaves. See, Hadoop follows master slave architecture, single master, multiple slaves, S1, S2, S3, S4, S5. See, multiple systems, a group of systems connected in a network. Group of systems connected in a network. Means one will be the master, all the remaining are going to be the slaves. This we call it as a cluster. This we call it as a cluster. We call this as a Hadoop cluster. Group of systems connected in a network. CPUs connected in a network. That one will be the master, remaining all will be the slaves. In Hadoop, we have got files. In database, we have got tables. In databases, we have got tables. Data is stored in the form of tables. In Hadoop, data is stored in the form of files. System 1 TB storage, 1 TB storage, 1 TB storage, 1 TB storage, 1 TB storage. Your file size is 2 TB. Your file size is 2 TB. 2 TB file. This 2 TB file cannot be accommodated in any of the system. It cannot be stored in any of the system where it has got only 1 TB storage. So generally in Hadoop, bigger data objects also can be accommodated. How come? Even if it is 2 TB or 10 TB, right? It will be divided into smaller parts. It is going to be divided into smaller parts. It is divided into smaller part. Each part is stored across multiple systems. Each part is stored across multiple systems. Means the bigger data file will be divided into smaller parts that are going to be stored across, distributed across multiple systems. They are distributed across multiple systems and processed by multiple systems parallelly. So your data, for assume it is stored in the 10 systems. 10 systems are storing this data and 10 systems are processing its data parallelly. That is what parallel processing. So two advantages. Data is stored across multiple systems and data is processed by multiple systems parallelly. Okay, processed by multiple systems parallelly. That's why very high speed. So that's why in most of the databases, no parallel processing, and a major drawback with the databases. So if a volume increases, if volume increases, speed decreases. If volume increases, if size increases, speed decreases. How come? So here, for example, if I take an SQL query, select sum of amount from sales table, from sales one, total amount from sales one. Think that it has got 10 records only. It has got 10 records. Similarly, select total amount from sales, total amount from sales table. It has got 1 lakh records. Assume it has got 1 lakh records. Similarly, total amount, right? Yes. From sales 3. From sales 3 has got 1 crore records. 1 crore records. 10 records, 1 lakh records, and 1 crore records, right? Which query is going to execute faster among these three? Which query executes faster among these three? Obviously, the first query.
Sales one.
First query, right? Because only 10 records computing the sum of total of this, only 10 records. First query to second query to third query. As the volume increasing, speed decreasing. Okay.
Vijay, you are not audible if you are talking.
Now am I audible to all? Hello?
Yeah, now I can hear.
Yes.
On four,
Previously,
four.
volume increases, right? Speed decreases previously. Total amount from sales 1, total amount from sales 2, sales 10 records, 1 lakh records, 1 crore records. Query to query as the volume increasing. Query to query as the volume increasing, right? Speed decreasing, right? Yes. So here, if complexity increases, right, speed decreases. Complexity means, for example, take the same table, it has got 1 lakh records you take. Even if complexity increases, speed decreases, right? Here, total amount from sales one, average amount from sales one, standard deviation of amount from sales one. Means which query executes faster among this? You all have got 1 lakh records in same table.
Some
Again, the first query executes faster, right? Because average, it's a two-step process. First sum to be calculated, next average to be calculated. 2 steps, right? So as compared to the first query, second query executes, takes more time. Standard deviation, lot of internal processing required. It is going to take more time as compared with the first two query. So query to query has this complexity increasing, speed decreasing, right? And the major drawback with the databases is databases can handle only structured data. Databases can handle structured data. They can handle only structured data. Structured data, for example, just check this. For example, if you want to take reviews for a particular movie, you want to take reviews for a particular movie, right? Yes. For example, this is your table. This is your table. User giving feedback or review. User and a review. This is a table. User 1, user 2, user 3. In this way, 100 users giving the feedback. User 1 saying the movie is good. User 2 is saying the movie is bad. Movie is good 1. If movie is bad 0. They are giving the feedback in the form of ones and zeros. If the 1 means it's good, 0 indicates bad. Can you write an SQL query to count the number of ones and zeros here? Can you write an SQL query to count the number of zeros and ones? Single grouping and single aggregation, right? Review wise count I want. Review wise count I want from the reviews table. From reviews table. Group by review. Review wise count from the reviews group by review. Just observe this output, right? Review wise means 1 or 0. Count. Review wise count. 90 people saying it is good, 10 people saying the movie is bad. 90 people saying the movie is good and 10 people, like nearly 10 people saying the movie is bad. You can write a query for this. But generally reviews won't be taken in the form of ones and zeros. Generally, they will be giving in their own text format. Movie, first person saying movie is good. Second saying movie is not good. A third person giving in their own text format. So can you write an SQL query for this kind of data?
no.
You cannot count, right? Previously it was ones and zeros. How many ones, how many zeros using count aggregation used. But this kind of data, right? You cannot, databases cannot handle. You cannot say how many goods and not goods. How many good and not good, right? Yes. Even if you, by using keyword counter, it gives wrong computation because even not good has got good in it, right? Not good has got a good in it. Okay, fine. So drawbacks with the databases, drawbacks with the current databases, right? Yes. Databases, no parallel processing. If volume increases, speed decreases. If complexity increases, also speed decreases. Databases major drawback can handle only structured, cannot handle unstructured or semi-structured data, right? Yes. Now, sir. Hadoop advantages. Hadoop advantages, right? Yes. Unlimited data storage. Unlimited data storage. Very high speed processing. A very high speed processing. Sorry. Unlimited data storage, very high speed processing. Can handle all varieties of data. Can handle all varieties of data. Structured, semi-structured, all varieties, right? Structured, semi-structured, and unstructured data. And no licensing. No licensing required here. And commodity hardware. Commodity hardware, right? Yes. Commodity hardware means it doesn't require, Hadoop doesn't require like highly configured systems. It can run on any system, right? It can run on any system, right? So unlimited data storage, very high speed processing because of this parallel processing, can handle all varieties of data, no licensing required, and commodity hardware. Observe, Hadoop was proven in the market. Hadoop is proven in the market. Processing point of view and storage point of view. Processing point of view, let's check this. Yahoo has conducted a test. Yahoo has conducted a test to check the speed of different databases. It has taken a table of 100 TB consisting of 1024 columns. Task, sorting based on 16 columns. Sorting based on 16 columns, right? Now, what is the time taken by different databases? Time taken, right? Oracle has taken nearly 3.5 days to process this. Has taken nearly 3.5 days to process. MySQL, it has taken nearly 6 days. Next, like specialized databases like used for data warehouse purpose, like Teradata. Teradata has has taken just 4.5 hours to process this. And later one more, Netija. Netija has taken 3 hours. Has taken 3 hours to process this. And finally, Hadoop has taken. Okay. Hadoop. Hadoop has taken just 3.4 minutes. Latest version of Hadoop taken 1.2 minutes. So this have taken days of time. This have taken days of time, right? Whereas Teradata and Netija has taken hours of time. But Hadoop has taken minutes of time. Hadoop has taken minutes of time. Compared with these days and these hours, compared with these days and hours, right? It has taken minutes. Still, I'm saying, even though it has taken minutes, I'm saying it is a slow processing. Hadoop 3.4 minutes, 1.2 minutes, right? So next, Later you have seen, later after introducing Spark. Spark, right? Already Hadoop, it has taken very less time, you are thinking, right? Spark 100 times faster than Hadoop. 100 times faster than Hadoop. 100 times faster than these things. See the speed of Spark, right? That is. So I'll be discussing, okay, Spark, right? Okay, if I'll give some introduction to this Spark. Just I'll take 5-10 minutes for this Spark, the importance Spark. What is Apache Spark? Apache Spark, and secondly, why PySpark? Spark with Python, right? We say like PySpark. Why PySpark? This course will be discussing like Spark with Python implementation, PySpark, and what is the need for PySpark? Need for PySpark, right? Yes. PySpark, real life usage, PySpark job market. So if I talk like Spark is a open source distributed cluster computing framework. It is a open source. It's a distributed cluster computing framework introduced by Apache Software Foundation. It is an engine for big data analysis, for processing and computation. Right? So why PySpark means? It is a Python API. It is a Python API to use a Spark. PySpark is the lightning fast technology that is designed for fast computation. It is one of the very demanding tool among the data engineers. One of the demanding tool among the data engineers to work with bigger data sets. This PySpark is used for running distributed SQL, creating pipelines, ingesting data to the databases, running ML algorithms, working with graph algorithms, working with the data streams, DS streams, right? So, and what is the need for PySpark? Means huge amount of data is getting generated. So the data will contain hidden patterns, unknown corrections, market trends, customer preferences, all this, right? So we are going to extract the valuable informations or insights from this raw data. So we require some efficient tool to perform this kind of type of operations on the big data, huge data. Already there were some tools, already we have got tools, right, available for this, but applied not on the huge data. But so we need to have a flexible and scalable tool to crack this big data and gaining some benefit from this, right? So PySpark is such a kind of tool. So combining Python and Spark will be the very efficient way for the world of this big data. So Apache Spark community came up with a tool called PySpark, that is Python API for using Spark. PySpark, okay, real life usage, where exactly it is used means in the commercial sector, it is used mostly for real-time processing. Banks and other financial systems, they are using this Apache Spark to retrieve the customer's social media profile, analyzing and gaining some useful insights which can help in taking the right decisions, right? And also in the fraud detections, in credit risk assessments, and also in the healthcare, in identifying, in predicting that patients based on the previous medical history who are going to face the issues. And entertainment industry, the most of the entertainment industry is moving towards this online streaming. The most popular OTT platform like Netflix using Spark for its real-time processing for this personalized online movies or web series. So this is going to process nearly 450 billion events per day. And even for trade in the e-commerce, right? Like websites like Flipkart, Amazon, all these e-commerce websites like Flipkart, Amazon, they're using Apache Spark for advertising, even for recommendations. So in different fields it is used. I will give examples of some of those. PySpark job market, right? So currently there is a great boom for this PySpark because of its very high speed, high rate of speed, right? That is the two processing huge data in quick time. So mostly used in this current market, right? Most of these ETL kinds of projects are migrating to this PySpark, right? So as part of this course, my major discussion will be on this PySpark, which has got a demand in the market. So if I see the course content, what I'm going to discuss, right? So just check with this big data Hadoop. First, I'll be discussing this knowledge. You'll be providing you with the knowledge, the required knowledge with this big data Hadoop, like what is Hadoop compared with other technologies. HDFS, Hadoop Distributed File System. HDFS architecture, name node, data node, secondary name node. MapReduce execution model. Previously, it was very much used. Now we are not using that much, but just I'll provide you the knowledge of it. Scoop, mostly used for import or export operations, for scoop importing or exporting. So the full form of scoop, SQL plus Hadoop, the first two characters of this, the last three characters of this form scoop. And during this import operation, during importing data from databases to Hadoop, lot of operations you can perform, right? Like filtering rows, filtering columns, mergings, groupings, aggregations, you merging, all this can be performed. Even for exporting data from Hadoop to databases. Yarn, yet another resource negotiator. What are the yarn components? How this yarn processing is going to happen? What are the various architectural components of yarn one by one? And one NoSQL, as part of this course, I'll be providing knowledge on one NoSQL database and one streaming component like Kafka, NoSQL, different types of NoSQL, and HBase is one of the NoSQL database. HBase architecture, perform HBase modeling, HBase CRUD operations, HBase and Hive integration. Next, the important component of Hadoop, Hive, which is mostly used. There are jobs available only on the Hive component, Hive architecture, Hive built-in functions, different types of tables where we have got HQL, which is similar to SQL, Hive query language, which is similar to SQL, inner tables, external tables, working with unstructured, working with XML data, working with JSON data, Hive working with URLs and weblog, Hive unions, Hive UDF, Hive UDAF, Hive UDTF. Hive UDF, UDAF, UDTF, partition tables, performance tuning mechanism, bucketing, indexing, Hive examples. So a lot of discussion on this Hive performance tuning mechanism like partitioning, static partitioning, dynamic partitioning, multi-column partitioning, bucketing and indexing, bucketing and partitioning, bucketing, indexing and partitioning, all the three, right? And coming to this PySpark in brief, what is Apache Spark? Need for PySpark, PySpark session, Spark context, broadcast variables, accumulators, PySpark RTD computations, persistence options, PySpark core computing, groupings, aggregations, various actions and transformations, PySpark SQL data frames, different data frame functionalities, like select, collect with column, where, filter, drop, order by, group by, union, union by range, and PySpark SQL functions, aggregated functions, window functions, date and timestamp, JSON functions, read and writing JSON, PySpark built-in functions, when EXPR lit split, overlay to timestamp to date. So this various and PySpark external sources working with the SQL, Spark and Hive integration, Spark and MySQL integration, working with CSV, working with JSON, narrow and wide transformations, handling nulls, joins, writing data back to this external sources, deployment modes, local mode, cluster mode, PySpark applications, right? States and tasks. Okay, PySpark streaming concepts integration with Kafka. And so for this PySpark, you require Python knowledge, right? Even if it doesn't have this, those who wants to prefer with Python or without Python. So with Python, right? So we'll all this Python core and advanced everything will be covered as part of this. So Python basics by Python history, applications, features, versions, installations, Python operations, Python modes of executions. Comments in Python, input output statements, escape sequences, strings, operators in Python, different types of operators. Python IDs, Anaconda, Jupyter, Spider, Eclipse, NetBeans, basic Python, flow control statements, looping statements, strings, collections, lists, tuples, sets, dictionaries, functions, different types, lambda function, filter function, map function, reduce function, modules, working with modules, modular programming, different ways of importing, renaming, reloading, packages, errors and exceptions, file handling, object-oriented programming concepts, regular expressions, database connectivity, date and time, OS module, web scraping, iterators, generators, closures, decorators, working with Excel workbook, data analytics for introduction to data science, pandas module in brief, NumPy numerical Python in brief, and a matplotlib plotting and visualizations. So this is what in brief it is going to be discussed about all these three things, right? So just observe this, right? So here, as part of this course, right? Yes, you'll be learning like Hadoop, PySpark, Linux, PySpark, sorry, Python. So this Python, right? It will be dealt separately. This Python will be dealt separately. You can attend any of my Python. I deal with Python batches also. So Python, like tomorrow, Monday. So core plus advanced both will be discussed. This Monday means the day after tomorrow at 7 a.m. There's a new batch going to start on it. And this coming Thursday at 7 p.m. there's a batch. And this total Hadoop, PySpark, and Linux. Hadoop, PySpark, and Linux, right? So will take like 12 weekends. 12 weekends, right? Nearly we'll be spending Hadoop, PySpark, and Linux. We'll be spending nearly 12 weekends, right? And the fees for this 15K. So which includes Hadoop, PySpark, and Python, right? So 2 hours on Saturday, 2 hours on Sunday it is going to be. And let me make it clear about the timings. Okay. But okay, so Hadoop, PySpark, Linux, and Python. So the first 2 weeks, the timing will be at this 4 o'clock, but later the timing will be from 7 p.m. to 9 p.m. First 2-3 weeks, it will be at 4 p.m., right? It starts at 4 p.m. Later, starts at 7 p.m. in the evening, 7 to 9. Okay. So this is what will be discussed. Okay, and you'll be getting the session videos. Each and every session video, right? Soft copy of this class notes. And there is a WhatsApp group. You'll be added into the WhatsApp group. Assignments and tasks to work with. Interview questions. Mostly asked interview questions, right? So this is what I am going to provide. Video session video, each and every session video you'll be getting for all this, right? Soft copy of the class notes, WhatsApp group assignments and tasks and interview questions. Okay. So tomorrow also you can attend the session at 4 o'clock to see more on this, right? More discussion on this. So before we go with, we'll be starting from the next week. Yes. At 4 o'clock only. When I said next 2-3 weeks, it will be at 4. Later it will be at 7 p.m. When any queries you have got, right?
Sir, Python would be in different batch. Yeah, you are only going to cover.
So here Python, because in the weekends it will be huge time it is going to take if Python is covered. This will be from Monday to Friday. Python is going to be discussed on from Monday to Friday, right?
Okay.
Monday to Friday, you can attend any of this morning or evening batch. Yes. Morning 7 a.m. or evening 7 p.m. Anything, you'll be getting the videos of it. Python is not that much complex language. Looks very simple, right? So, and this Hadoop PySpark and these things will be discussed in the weekends. 2 hours on Saturday and 2 hours on Sundays.
Sir, 12 weekend is enough for this Hadoop and PySpark and Linux.
3 months, 12 weekends means what? 3 months.
Okay, sir.
And like session would be all theoretical or including practical?
So everything will be practical oriented. There's nothing theoretical. First 2-3 sessions will be describing what will be discussing about these things, right? But later everything it will be practical. It's no theory. Means everything I'll be showing you with clear notes you will be getting what we are performing. Right?
And any like live project or any project?
So at the last I'll be discussing one flow, right? Project flow.
Okay.
So don't worry about these things, right? Everything you will be understanding clearly. And you're not going to write huge codings here. You're not going to write any huge codes. Everything we have got built-in functionalities available. Which functionality to be used when you need to understand. And I'll be showing you on different environments how to run and how to execute these things, right? So in this normal, I'm going to provide you the software to your Google Drives. From there, I will just demonstrate how to work with it. Later, I'll be showing you how to run these things in the Jupyter Notebook and in Databricks environment, in this Cloud Era environment, right?
Sir, what kind of laptop, what configuration of laptop do we need for running the projects?
See, what I say is any whatever it is, but if you are able to have minimum 8 GB RAM, minimum of 8 GB RAM, right? So even if you have got less RAM also, the thing is you will be having less speed, processing speed. If you're typing any command and if you're executing it, right, it takes a little bit time. If you have got 8 GB or if then higher than that 16 GB or more also, it's fine. But 8 GB, if you're unable, if you have got less than that also, but it is going to take time. Every time typing some command, it takes some time to view the result. So it can I can provide you the software which works on any of these systems. Even if you have got older systems also, I can make it. And also if you have got new systems with highly configured, right, you'll be having good speed. Right? So not worry about these things. I'll be providing you the softwares, how to, and I'll demonstrate about it, how to use and how to work with. Right? And the prerequisites, right? Basic SQL knowledge and Linux. Anyhow, that Linux commands I'll be discussing as part of this before I go with that practical part. And also Python I'll be discussing here. Yes.
So the classes will be on the weekends, but if we have any doubts while running the code or doing the practicals, lab practicals, so will you be available?
So a WhatsApp group is created for that purpose, right? So if you got any error anywhere, right, you can take the snap of it and keep in the WhatsApp. Anybody can answer, anybody in the group can answer that, and even I'll be answering it. And even if that error is without, we cannot, I'll be giving the time for you to, even if it is the error needs time, right? So I'll just providing some time. Okay, just join this set so and so time. So means this Saturday and Sunday again you will be meeting on the next Saturday. No need to keep that error up to the next week. So either you can interact with me, otherwise you can the error. Otherwise I'll be calling you to rectify that error.
Sir, Scala also we are going to cover?
No, scale is Spark with Python implementation, not with Scala. Scala previously it was used a lot, but currently mostly in the industries now Spark with Python is preferred.
Okay.
Scala is also used currently. I'm not saying that it is not used, but Spark is the execution model. It can be implemented in the multiple languages. Python, Scala, Java, and R language. Java and R language never preferred. Python and Scala are preferred. Previously, Scala is preferred a lot. Now Python is mostly preferred. Previously, I used to take a lot of batches on Scala. Now mostly on Python, PySpark.
Okay. So this Python batch we can start to join from next week, either Monday, yeah.
Day after tomorrow, right? You can attend those things, right? Day after tomorrow, you can see in the chart, right? You can see in the chart. 1 second.
Okay.
The contact details are provided. The
So
payment
this
details.
Python batch, how much time it will take to complete?
Python core and Python advanced will be taking nearly like 45 sessions on that. 45 to 50 sessions. Takes
Okay.
like it also takes will in brief in depth we'll be discussing, not an overview, right? Python total Python knowledge will be getting core and advanced. Like 1.5 to 2 months it takes. Means
Okay.
for starting with the PySpark, right? But initially this Hadoop will be discussed. When you Hadoop is discussing, right, you will be parallelly learning with Python. By the time Hadoop completes, your Python core gets completed. So that Python core knowledge is enough for this PySpark, right? Yes.
Yes. So Spark we can use with the Python also, and we can use with Scala as well.
Yes.
Okay. Sir, basically I am Java backend developer. So is it good like if I join this course and do this?
See one thing, right? To install the software of this Hadoop or PySpark, all this without Java, it cannot be installed.
Okay.
And here previously in Hadoop, Java was mostly used. Previously, only Java people used to update with Hadoop in 2011, 12, 13, right? But slowly, because of these huge codings, very, very huge codings, right, in Java programming, people started migrating to other technologies. Slowly, the usage of Java got decreased in this. The many other things were introduced in this Hadoop and PySpark. Now, we are not going to see that codings of this Java. Like later, Scala is next Python you have got, right? So where you can see the less codings. If Java is used, lot of codings, lot of packages, things, all the things will be there to overcome it. So currently Scala and Python. Even Spark can be implemented using Java language also, but not preferred in the industry. Currently they are using Python and Scala.
Okay.
Fine. So tomorrow also people can attend the session at same time at 4 o'clock. More discussion tomorrow, right? Yes. Fine. Any other queries, right? Okay. So if I'm done with your queries, if there are no other queries, I will sign off for now. Meet you tomorrow at 4 p.m. using the same link, right?
Sir, project and we
Yes,
will cover project.
yes, I'll be discussing one at the last.
Okay.
Okay, it's fine. So I'm signing off for now. Meet you tomorrow, right? Thank you all for your time. Thank you. Meet you.
Thank you.